And so for Pythagorean identity, if you think of how a circle is formed, we can make the circle, the point on a circle makes a right triangle. That right triangle has a Pythagorean identity. We know that this length squared plus this length squared equals the hypotenuse squared. Or in other words, if this is a unit circle, cos is the x coordinate position, sine is the y coordinate position, and we end up with cos squared plus sine squared equals 1 squared, or cos squared plus sine squared equals 1. Now these have rearrangements on these Pythagorean identities can be rearranged to form these other Pythagorean identities. These are related identities. If I just move the sine squared to the other side, I get 1 minus sine squared equals cos squared. And the same thing could be done if I want to subtract cos squared from both sides. I end up with 1 minus cos squared equals sine squared. These other identities, we can look at them from a couple different perspectives. They themselves are Pythagorean identities. I'll show them at the end of these notes. And we can actually make the right triangles for these. But probably a little bit more easily done is if we take a look at these identities from just a rearrangement of these identities. So or an algebraic manipulation of these identities. So if I take this cos squared and divide every term by cos squared, okay, I still have an identity because this is still in balance because I've kept it balanced. But cos squared divided by cos squared is 1. Sine squared over cos squared is tan squared. 1 over cos squared is secant squared. So if I divide by cos, I end up getting this identity here. Okay, we can generate the cotangent identity by doing the same thing, by dividing by the same identity by sine squared. So if I divide everything by sine squared, well, sine squared over sine squared is 1. Okay, if I divide cos squared with sine squared, that's going to generate the cotan. And if I divide the 1 with sine squared, okay, I've kept this whole expression balanced, so it's perfectly okay, and that generates the cosecant squared. Okay, so we end up with these two identities are just algebraic manipulations of these ones. We'll show the first one. So I'll show this in its own triangle later on, but essentially this identity here is really a key identity when it comes to the circle.